It may not be obvious, but operations are actually trees. For example, consider the following operation. This is a multiplication whose inputs or child expressions are 2 plus 3 and 4 plus 5. The two child expressions are both additions whose inputs or grandchildren are 2, 3, 4, and 5. Here is the expression family tree. Nodes contain values. We don't know the parent node values until we evaluate operations, so they contain variables x, y, and z. We want to know the value of z. We can see that z is equal to x times y. Thus, we need to first know what x and y are. We can see that x is equal to 2 plus 3. Thus, x is 5. Next, y is equal to 4 plus 5, so y is 9. Then z is equal to 5 times 9, which is 45. Here is a more complex example. 2 plus 3 plus 4 plus 5 times 6 plus 7 plus 8. Here the child expressions are 2 plus 3 plus 4 plus 5 and 6 plus 7 plus 8. The grandchildren are 2, 3 plus 4 plus 5, 6, and 7 plus 8. We also have great-grandchildren, which are 3, 4 plus 5, 7, and 8. Finally, there are two great-great-grandchildren, 4 and 5. And here is that expression as a tree. Take a moment and try listing the operations in order. As before, we want the root value, or f. We know that f is equal to d times e. Starting with the first input, we know that d is equal to 2 plus b. Next, we need b. We can see that b is equal to 3 plus a. And a is equal to 4 plus 5. Thus, a is 9. Then b is equal to 3 plus 9, which is 12. And d is equal to 2 plus 12, which is 14. Thus, f is equal to 14 times e. Next, we need to know e. We can see that e is equal to 6 plus c. And c is equal to 7 plus 8. So c is equal to 15. Then e is equal to 6 plus 15, or 21. Thus f is equal to 14 times 21, or 294. Notice how we traverse the tree in depth-first order. In general, here's how we calculate the value of a node. If the node value is constant, then the output is simply the constant value. If the node is a variable, then evaluate the left child, evaluate the right child, then calculate the output using the left and right children inputs.